நேற்றுக்கு அப்படி தான் இந்த ஆஃப் ஆயிடுச்சு, அதனால தான் இப்போ திரும்ப எடுக்கிறேன். மேம் 12:40க்கு அப்புறம் நீங்கள் பேசுறதுலாம் எனக்கு வந்துடுது, அவங்க கட் ஆகிடுது, அதனால தான். முரளி சார், so good afternoon, one and all present here. I welcome all of you for this virtual classroom. And today we are going to see the three topics in the packaging, MEMS packaging. So the topic number 1 is the level of different levels in packaging. Essential package, then bonding. So bonding we can classify into two. One is permanent bonding. Next one is called temporary bonding. Right? So let's start from topic 1. So now there are three levels of packaging. So one called die packaging, device packaging, and system packaging. To explain this, I have to take care of the pressure sensor. So with the help of pressure sensors and its own instrumentation amplifier and its own power supply and its display, along with that I am going to explain three levels of packaging. There are three levels. One is die packaging, device packaging, and system packaging. So So this is the cross-sectional view of This is cross-sectional view of device call it as a pressure sensor. Let me see the principal operation of this pressure sensor. So this is the cross-sectional view where the pressure measurement device or die, silicon made die or diaphragm is located here. Inside this diaphragm is completely sealed with the plastic mold along with the metal contact. And this inside I will call it as a cavity, right? This cavity having its volume, let us take 1 mm volume. If I'm going to access the flow, maybe the gas will flow in or out. This will flow in and out, will vary the concentration and amount of gas vary inside the cavity. So that will try to change the diaphragm. It could either deflect, it could either move ups and downs. So that movement will change the resistance. So any gas flow that will change the diaphragm of this cavity, that changes will changes the resistance because this is made up of piezoresistive material. I will repeat the sentence. This is the cross-sectional view of the pressure sensor. What is pressure sensor? Pressure sensor used to measure the pressure level inside the cavity. When I am going to pump the fluid or a gas inside the cavity or taking out, so this will change the diaphragm movements, displacement of the diaphragm. That displacement changing the resistance of the given diaphragm. Why? Because the diaphragm is made up of piezoresistor along with the diaphragm is coated with the piezoresistor along with the silicon diaphragm. So this is cross-sectional view. So this whole structure I could call it as die. I could call it as die, right? I could call it as die. Die is nothing but a piece of semiconductor which holds complete circuitry, electronic circuitry or digital circuitry or even a sensor or even actuator with that. So this whole thing could be the part and parcel of a simple die. What is die? Die is nothing but, let us take the example of the full wafer. So this is the full wafer with the with orientation mark. This is the orientation mark. So it will be flat. Based on this, we can call it as, we can understand either the p-type device is 100, it could be 110 or 110, 111. So these are all orientation. So let us take what is die. So die is nothing but a piece of semiconductor from the silicon. Let us take this is a die 1, this is a die 2, this is a die 2, die 3, so die 4. So like that, every square it has its own die, right? Right? So every wafer having its number of die. So a single die I could call it as, this could be the pressure sensor and this could be the gas sensor and this could be the actuator, anything. So we have n number of dies. So single die could be like this. Then how could I understand level packaging? There are three levels. One is die. There are three levels. One is die packaging. Second one is device packaging. Third one is called system packaging. So this could be the part and parcel of the Weinstein bridge, right? So what is Weinstein bridge? We'll see. So this we call it as RZ, right? So this is RZ. So what is this? So this die could be the part of the bridge, right? So the bridge could be excited by a battery source or a right external voltage. Now the imbalance could be measured using instrumentation amplifier. So this could be measured with the help of instrumentation amplifier, and instrumentation amplifier will process and gives the output to the signal processing unit, signal conditioning or processing unit, and this, right, called as device, right? So what is this? This is called die, right? So after signal processing, it directly having its own display device. Display may represent 0.07 Pascal. So this is the output or display. It could be high display. So the system should be operated with power supply, right? So it has a power supply unit, right? So this is the die package. I would say die is connected with the Weinstein bridge, and this whole thing, instrumentation amplifier with Weinstein bridge, I call it as a device packaging, right? This is die packaging, right? This including power supply, call it as system, right? System packaging. So now you understand the different levels of packaging. So there are three different levels of packaging. One is die packaging, which includes a small piece of semiconductor which holds the pressure sensor. So the cross-sectional view of RZ nothing but this, and this RZ is the part and parcel of the Weinstein bridge. So the Weinstein bridge is excited by the power supply to do the balancing operation, and any imbalance that could be taken as a difference voltage across this, and that difference voltage will proportionally indicate how much pressure getting into the pressure sensor. So this is the display which shows how much pressure which is excited by the external source called gas and fluid will get into the cavity. So this is what I could say the different levels of packaging. Now we'll move on to next level, right? Essential packaging techniques. So essential packaging. So essential packaging, the first one is called die preparation. So what is die preparation? As I mentioned, there is a wafer. So there is a wafer. So in that wafer, we have number of sources of dies, right? So die is a complete chip or a complete circuitry, right? Die is a complete. This is die 1, die 2, die 3, die 4. So this is a single wafer, right? I could call it as a fabricated wafer. Fabricated wafer disc, right? So what do you mean by fabricated wafer disc? So this wafer having number of components 1, 2, 3, 4, 5, 6, 7, 8, 9. So n number of die available. Each die having its own design. Then die 1 could be your pressure sensor, and die n could be your tactile sensor. This can be gas sensor. This can be actuator. So a single wafer having its different devices, maybe sensors and actuator can be fabricated, or the identical device can be fabricated on the single die. So what I'm trying to say? This is the die preparation, which means after fabrication, I'm going to remove. I'm going to using a special cutting tool, call it as a diamond cutting tool. Using special cutting tool, I'm going to slice down or dicing this wafer into single pieces. So I have a number of pieces like that. So each piece having its own die, right? So this piece could have a space difference between dies. It could be 20 micrometer space difference between these two dies, and 50 micrometer 50 micrometer space between die, and the thickness, the cutting tool edge, or I could call it as a blade, right? So I could call it as a blade thickness. The blade thickness could be 20 micrometer, and the slicing speed is around 30,000 to 40,000 RPM. Wafer slicing speed is around 30,000 to 40,000 RPM of wafer dicing. Wafer dicing speed. So with the help of this much speed, I could cut even more number of wafers into number of dies. So this is called die preparation, converting a unique wafer, fabricated wafer into number of dies, right? Now we'll move on to the topic called bonding, right? So what is bonding? Bonding could be classified into temporary bonding and permanent bonding. What do you mean by bonding? Bonding is nothing but attaching two different pieces, right? The piece number 1 and 2, I could call it as A and B. These two pieces it could be silicon on non-silicon base, or metal or glass, and so on. Like this also could be a silicon or silicon dioxide or silicon nitrate or platinum or nickel, etc. So bonding is nothing but adding two different material or same material to make into single piece. So either I could apply heat, or either I could apply voltage or some chemical. With the help of this, I'm just converting two pieces into single piece. Two piece into single piece. This is called bonding. What is bonding? Converting two simple pieces into single. These two simple pieces could be either silicon or non-silicon material. Then why we need bonding? Why we need bonding? Why? There are so many factors associated with that. As I mentioned, if we take any complete device, for example, take a gas sensor, right? Let us take a gas sensor, right? Let us take gas sensor. It has a silicon substrate, followed by silicon dioxide, and followed by polysilicon heater, followed by silicon nitrate, right? And followed by platinum electrode, and followed by a sensing layer. It could be is that a no. So this is a gas sensor, right? So you understand a sensor could have number of layers. A sensor could have number of layers. This could be developed by either deposition and etching technique, either for positive photoresist or negative photoresist. And one thing you can understand that whole piece, this whole piece, not more than some micrometer, not more than some 500 micrometer, because everything in the form of maybe 100 to 100 micrometer to 500 micrometer whole thickness, because this is developed on the silicon substrate. So silicon dioxide could be developed by heating, polysilicon can be developed by PVD technique, silicon nitrate can be developed by chemical technique, CVD technique, PD can be developed by sputtering or thermal evaporation, sensing material also deposited using CVD or PVD technique. So this is a sandwich of the different layers, right? This is one way. The other way, as I mentioned, this is a die could have like this. So die could be, right? This is a die, right? A gas sensor die, right? So when you go in depth, you will have number of layers. Then my point is different. Why bonding is required? We know that we have different rules to develop different layers, but instead, what is bonding? So bonding is merely required. Why? Because all the layers are vary from nanometer to some few micrometer. Generally call it as thin, right? Generally call it as thin layer. So these layers are very thin, vary from nano to few micrometer, right? So you understand these are all very thin and very fragile in nature. So we need some support. For example, if I am going to add these two things, now I could call something, it is called it as thick, right? So converting thin material into thick, right? And thick material normally provide mechanical support. Normally provide mechanical support. Normally provide mechanical support. So this mechanical support or electrical support, or it can be electrical contact, right? This die factors could provide some electrical contact. It may provide electrical contact too, right? So I need bonding because my layers are very thin nature. So when I'm worrying about very thin, it could be very flexible. It could be either it could convert normally from thin layer, so it could convert from stable into unstable by means of cracking, mechanical cracking, some instability, some flexible. So it may affect it may affect the physical, mechanical, electrical, chemical property of the die. So I need some support called thick die. That support, if I need during during fab, then I call it as temporary bonding. Suppose that bond, that particular thin layers, let us consider this is my gas sensor. Now this gas sensor should have electrical contact, right? Now let's say this is after fabrication. So after fabrication, I'm going to have now one PCB, right, supporting bond. From here I'm going to provide electrical connection over here, and again it's still extending the electrical connection, right? Electrical connection over here, let us assume, right, over here. So my bonding is required. Why it requires? Because anything, if it is belongs to thin family, naturally vary from nanometer to micrometer, I need a support. That support, if I need it during fabrication, then I could call it as temporary bonding. If the support or mechanical support needed after fabrication, then I could call it as permanent bonding, right? So bondings are naturally classified into what is bonding? Adding same or dissimilar material into single piece, right? So bonding is naturally temporary and permanent. What is temporary? During fabrication. What is permanent? After fabrication. So after fabrication, my gas sensor having its electrical and mechanical contact with the external, right? So I could say as permanent. But during some fabrication process, if I need a bonding, if I need a support, then that is called it as temporary bonding. Now, one more problem, because this is permanent, we are not worried about the bond, we are not worried about bond because it's permanent. And what is packaging? Package must ensure the device from harsh environment. It should not expose, or it should protect the device from harsh environment, as well as the device must be exposed, or device must be transparent to the target material. It could be the gas. So the bonding is permanent sometimes after this, but the temporary bonding during fabrication, I have to remove or release this temporary bonding. So I have to release this temporary bonding. So how could I release? There are four techniques available to release the temporary bonding, right? So temporary bonding must be released from four techniques, either by thermal or by chemically or by laser, thermal, chemical, laser, or by then mechanical. So there are four different release available. So there are four different release. So there are release techniques. Either by thermally we could remove, because this is temporary bond. I have to remove a thin material from the thick support, a thin device from the thick support, where during process. So after fabrication, I am going to fix the die into some other place. So in the temporary bonding, I need a process called release process. I should release my die from the bottom or from the support. So how to release? Either by application of thermal, or by chemical, or by laser, or by mechanical. This is the fourth method or technique to release the temporary bonding. We'll see one by one. So let us consider a thin support. So thin die process. So this could be a silicon or non-silicon, right? So I need a support. So the support could be a bit or thick, right? This could be 1 micrometer. This could be a 100 micrometer thick support, or 500 thick support I needed. So there are four different techniques were there to release these things, right? So we'll see one by one. One is called direct bonding, right? Right? So this is four different releasing techniques we are here. But before going with the releasing, we'll see there are four different bonding is there to make sure the bonding, right? We'll see after seeing the four different bonding techniques, we'll see releasing technique, right? So we'll see first bonding. There are four different bondings available. So one is called fusion bonding. Second one is called anodic bonding. Right? Anodic bonding. Third one called equatic bonding. The fourth one called adhesive bonding. Anodic, right? So there are four types of bonding. Types of bonding. So one is fusion bonding. Next one is called anodic bonding. Third one is called eutectic bonding. Fourth one called adhesion bonding. What is anodic bonding? Anodic bonding, we are just taking care of two single pieces. That is, it's very thin by nature. So I'm going to apply a mechanical force of 3 megapascal, and as well as I'm going to maintain the temperature of this is around 700 degrees Celsius. By electrically I'm going to heat, I'm going to get the temperature. So the temperature would become 700. By thermometer I could understand. Right? By thermometer I could understand the 700. This is called fusion bonding. So fusion bonding is nothing but adding silicon with silicon. After this, so these two become a single piece of silicon, right? It's called fusion bonding. Then it's called anodic bonding. What is anodic bonding? Anodic bonding is similar, but except that I'm going to apply a regular voltage across this, right? The voltage would vary from 200 to 1000 volt. 200 volts to 1000 volts, as well as the pressure. The temperature here it is less than 500 degrees Celsius. It's called anodic bonding, right? Analytic bonding, mechanical bonding, and analytic bonding, direct bonding, and adhesion bonding with the help of some chemical substances. So we are going to add both the silicon into single. That's called adhesion bonding. Etotic bonding, I could say there are two dissimilar material having its own different mismatching of the coefficient that could be dealt with the help of high voltage, high pressure and power. So that's called etotic bonding. These are all the four different bonding. Now we'll go to release. How to release? Either by applying temperature. Either I'm going to apply temperature. Let us take, this is one piece of semiconductor, this is other piece of semiconductor. This could be removed by apply heat. This could be removed by apply heat. So this heat will make some fluid, it will make weak in the bonding because it's the temporary bonding already. So it will make a fluid or melted. Maybe the heat is less than the melting point. For example, silicon is equal to 1400 degrees Celsius. So the heat should be less than that of this. So this will equally remove. What is called chemical bonding, chemical release. Again, there are two silicon having its own bonding. So I'm going to apply some chemical through hole, through some hole, through some hole. I'm going to apply my chemical. So the chemical is easily reacted and made into fusible or diluted. So now could be released easily or by laser. What is laser? What is laser? Again, there are two pieces of semiconductors. It may be silicon or non-silicon based. So when I am applying laser over that, so this will make diluted nature in between these two. So with the help of laser, I could remove silicon from substrate. The substrate could be a polysilicon or PCB or anything, right? With the help of laser, I could remove. Then finally mechanical. It's very simple technique. So, and I'm going to just simply peeling off by applying force. So just peeling off, right? By applying mechanical energy to remove the silicon or support, it could be the support PCB and your silicon die is as such, and it has, because you know silicon is very stable and very stubborn and strong material available in the world. So I could easily apply mechanical force to remove the support, or I could apply laser to remove this. So the laser again is reacted with this center portion where it is diluted. So this will easily remove, or by applying some chemical, or by applying some heat, right? So the heat should be less than the temperature of the silicon as well as support, right? So these are the four releasing techniques. Where I'm using releasing techniques only at the temporary. Where I'm using temporary during fabrication. Where I'm using permanent after fabrication. What is bonding? Joining two dissimilar metal or same metal, same material with the single piece. What is the essential of the packaging? These are all the essential of the packaging. This comes under die preparation, wafer preparation, bonding, and all comes under essential of the packaging. So what is three level of packaging? Call it as die packaging, device packaging, and finally end up with the system packaging. So that's all about the today's session, and I will ask you, my dear students, I will ask you to submit the assignment through Google Classroom. So the assignments are, please note down, right? What are the different types of, what is packaging? What are the different types of packaging available? And what do you mean by different levels of packaging, right? Explain different levels of packaging, and also explain different essential packaging techniques and bonding techniques, right? That's all. So what is packaging, and what is different packaging technique available, what is called different levels of technique available, and what is essential packaging, and what do you mean by understand bonding, both temporary and permanent bonding, right? So this you write the assignment submitted through Google Classroom. Otherwise, I wish you all the best for your forthcoming examinations, right? So you prepare well and do well, and that's all, right? If anything you have a doubt, you can post your question through Google Classroom. I think 38 of you is available in Google Classroom. You just ask whatever you have your doubt, right? Maybe point of understanding, point of packaging. You can post your questions through Google Classroom. We are there to support you, right? Do well. Thank you for listening. So through this video, I request all of you just go through the unit number 4. It's very packaging is a very important topic. You can use the material what I gave through WhatsApp, or you can go the textbook called SM Zoo, right? You can use the Zoo book. It's 11th chapter. So packaging concepts are available very clearly. You can use uh, zoo book and find the answers. And also try to remember, don't copy the answers and don't scan the answers from others. You all of you just individually go through the answers and read well and write the document and submit it to the either WhatsApp, but probably it should be accounted through Google Classroom. So go Google Classroom, you can submit your assignment as well as you can raise your questions there. Unless yeah, we'll have a next session on tomorrow, same time. Right? Don't forget to watch your classroom teacher. Right? Thank you for listening. That's all.